Welcome to our webinar with from Toronto Agile community with JB Rainsberger. Today's webinar is going to be Surviving Legacy Code. It will be recorded, so you can have a chance to follow up with this after, or share it with your friends, or show it to your colleagues that probably will benefit from it. Just a couple of things before we start. One thing that would do today is talk a little bit about JB, who is. Then we're gonna give the presentation platform to him. We're gonna follow up with questions after, and then we're gonna have a closing and upcoming events from the Toronto Agile community. So, first of all, welcome from Toronto Agile community team. One of our main goals is to help our community grow, and this series of webinars is part of this goal that we are trying to work on towards by increasing the number of events, by increasing the number of information that we bring to you in order to help you not just overcome the challenges that you have every day, but even to learn new things and to spread the knowledge around with your friends and colleagues. Before I pass the baton to JB, I want to talk a little bit about JB, who is, he is one of those developers that we are proud to call him our own. He helps software companies to satisfy not just their customers, but even their businesses that they support, and create more clients, bring more successful stories. He has learned over the years, probably in painful ways, that he can write valuable code, he can enjoy working, and he can have a life that he loves to live. And he's trying to pass this even to others, developers or non-developers, by helping them with their work, by giving them advices, by helping them to do their best with minimal investment. JB does this by offering different trainings that he has, custom consulting, and he also has his online videos that you can go and you can join him online sessions, learning sessions to help you with any problems that you might be facing. So this is more or less who JB is, and we are very proud to have him today as one of our presenters. Before we move on, just a little bit of housekeeping rules. I have put you all on mute, just to avoid any external noises that you might have around you, and make sure that everything goes smooth. You do have the option to post questions during the presentations. We have the chat box where you can put your questions, and at the end, after the presentation, JB is going to answer to all of them, or some of them, depending on how many do we get. In case of any technical issues that you might face during the recording, during the webinar, I would probably ask you to try another browser or try to log off and log on. If you have issues with the audio, usually try to check if there are other applications on your computer that are interfering. So, with that being said, I'll pass the floor to JB.
Hi, I'm Jay Brains, and this is Surviving Legacy Code. So what is legacy code? Well, the word legacy would kind of imply old and inherited, and that's how I remember learning the term. But for me, the meaning of legacy code has changed a lot over the last 15 years. And in particular, I was strongly influenced by Michael Feather's book, Working Effectively with Legacy Code. In this book, Michael talked about the idea of legacy code being not necessarily code that somebody else wrote 15 years ago on an old platform where maybe we've lost the source code, but he talked about legacy code as being code without unit tests. I would go even one step further. Why is it that we care about whether the code has unit tests or not? Does the word unit really matter in unit tests? What is it about code without unit tests that made Michael so sure to call legacy code that as opposed to something else? As I was thinking about this, it came to me that really the point of the unit tests is that having unit tests, or as I prefer to call them now, micro tests or even just small tests, having tests represents confidence in changing the code. And so maybe legacy code is simply code we're afraid to change. But then it seems to me that code we're afraid to change doesn't really tell the whole story, because there's lots of code that I'm afraid to change that really doesn't matter that much, and so we just throw it away. In fact, maybe the easiest thing to do with code that you're afraid to change is to throw it away and try again. So why don't we? It seems to me that the reason that we don't throw that code away is because it's providing value. That, to me, is the real difficulty in working with legacy code. It's not just that it's code we're afraid to change. We could just throw that away. It's that it's valuable code we're afraid to change. In fact, it's really valuable code we're afraid to change. So valuable, probably, that if the company had to choose between us and the code, they'd choose the code. So when I'm talking about legacy code, I don't just mean old code that we've inherited that we have to deal with. I don't even mean just code we're afraid to change, or code without tests, or code we don't understand, or code written on an old platform by other people 15 years ago. I really mean valuable code we're afraid to change. Very valuable code we're afraid to change. Its value means that we really need to treat this code with a certain amount of respect. We can't just walk in and decide that we're going to throw it away and start again. If it were, then really there wouldn't be that much to talk about. Instead, we need to balance our respect for the value that the code provides with a certain disdain or contempt for the way it does that. The value of the code is the asset, but the design in most cases is a serious liability. And surviving legacy code really boils down to navigating that fine line between reverence for the value that the code provides and disdain for the way it does it. That's what makes surviving legacy code so difficult, and the reason that I wanted to talk about it today. Because legacy code is code we're afraid to change, it seems to me the most reasonable place to start, even before we start changing the code, is to set up an environment where we feel more comfortable changing code, where we can make some mistakes and recover, where we don't have to worry as much about what happens. What we really need to do is optimize for safety. For me, that's the number one, maybe the number 1, 2, and 3 rules of working with legacy code. Optimize for safety. By optimizing for safety, the number one thing I mean is to drive down the cost of making mistakes. It's not that we want to make mistakes, but we know that working with legacy code, mistakes are inevitable. We're going to try some things, see how they worked, and then have to throw a bunch of it away, especially when we reach a new part of the code base where we don't have a lot of experience and we really don't know just how bad it is. It's very important for us to be able to experiment, try some things, keep the stuff that works, and throw the rest away. And that's part of what I mean by optimizing for safety. We want to make it so that changing the code, although it is expensive, can be as inexpensive as possible. The two ingredients that I think most strongly go into making legacy code less expensive to change are adding tests and being able to roll back. To me, those are the two most useful tools we have in our toolbox. And so a lot of the work that we do with legacy code will consist of adding tests and being ready to throw things away. And so before you even begin trying to change any legacy code, maybe the very first thing we need to do is to make sure that we have an environment where we can roll changes back. That can be as simple as installing one of the modern
version control systems like Git or Mercurial or Bazaar or Darks, whatever your favorite is, but one of the lightweight version control systems. The idea is to be able to use version control for yourself, even if you're not going to use it that way with the rest of the team. So if the project is using Subversion or Perforce or CVS or even RCS, that doesn't have to stop you. You can install a Git repository alongside whatever repository you use to share code with the rest of the team. And that way, you can commit changes very frequently as you're walking through the legacy code, throw the stuff away that's not working, and then when you're ready, take that big batch of changes and either commit it and share it with the rest of the team, or decide, well, we learned a lot, let's just throw it away and try again later. Another powerful technique we can use to make rescuing legacy code safer is to add tests. Of course, this creates the chicken and egg problem. We already know that we want to break things apart, so we want to write some tests so that we can break things apart more safely. But we need to break things apart in order to be able to write the tests that we want in order to be able to make it safer to change the code. We know that if we start with these end-to-end tests, that gives us a certain level of security, but not that much. Those big end-to-end tests will help us know that we haven't obviously broken things, but they don't detect mistakes nearly as well as microtests do. Unfortunately, we can't write microtests until we break things apart because legacy code is usually heavily interdependent code. Everything's wired to everything else, and it's difficult to write tests that are this small. This is probably the biggest code problem that we're going to deal with in surviving legacy code, is that balance between refactoring so we can add tests and adding tests so that we can refactor safely. You'll see this as a recurring theme as long as you're working with legacy code. Because of this chicken and egg problem, one of the skills that I had to develop in order to rescue legacy code effectively was to feel comfortable refactoring even before I had all the tests that I wanted. And there's two ways to go about that, at least that I know of. One of them is simply to practice. And I don't mean sitting there and going inline, extract with some code. But what I mean is the more I practice test-driven development, even not in legacy code situations, the more comfortable I felt refactoring in general. And in particular, the more comfortable I felt in leaning on the refactoring tools that I had available, or on understanding how to do some of the basic refactorings so precisely and so carefully that the tests were really there to catch the occasional mistake rather than being an integral part of what I'm doing. Now, I don't want to underestimate the power of those tests, but there are some refactorings now that I feel so comfortable doing that I'm willing to do them even without all the tests that I need. That's not to say that I prefer to do them without tests, but it means that if I have to do them without tests, I feel comfortable. Now, refactoring without tests, or tightrope refactoring as I like to call it, isn't easy, but there are a couple of things that we can do that help with that. One of them is simply to practice test-driven development and refactoring it. The more comfortable I feel refactoring in general, the easier it is for me to justify refactoring without the necessary tests, or without the tests that I'd like. Unfortunately, working with legacy code, you really can't avoid that. There are going to be situations where you're going to need to change code even though you don't have the tests you wish you had. Remember that whole chicken and egg problem. So one of the things that we can do is simply develop our skills in refactoring and being, generally speaking, more comfortable in performing refactorings correctly. I can remember when I first started, I read the book Refactoring, and I would literally have the book open and would follow the step-by-step instructions about how to extract methods safely, or how to move something from one class to another, or from one module to another. And I would literally practice those steps until I could do them, until they were, as piano players call it, under my fingers. I could do them without really thinking about it. Now, of course, we have automated refactorings that help with that now, but I can remember the early days of automated refactoring tools, and they didn't always work. They are software like anything else, and sometimes there are mistakes. And so even though I have automated refactoring tools to depend on, that doesn't mean that I treat them as though they will always work entirely perfectly correctly. And so noticing which refactorings I can do without making mistakes, which ones where mistakes are very, very infrequent but sometimes happen, and even knowing for which refactorings the kinds of mistakes that sometimes happen, that makes it a lot easier for me to feel comfortable doing something, changing code, refactoring even before I have all the tests I want. And so what I try to do is refactor as little as possible with the goal of being able to add more tests. And so that means that I get really good at the breaking big things apart into slightly smaller big things refactorings, and doing that even without all the tests I want. And then once the pieces are small enough that I can justify adding 20 or 30 tests around this part of the system, then I can really start breaking things apart and feel a lot more comfortable. So that's one thing that I can do. The more that I felt comfortable refactoring in general, then the more comfortable I felt refactoring before I had all the tests that I want. Of course, this is also where version control really helps, because if I can't have all the tests I want acting as an ongoing, continual pool of change detectors, that red flashing light on your laptop that says, hey, stupid, you made a mistake in the last 15 seconds. That's what tests gives me. But if I can't have that, then the next best thing is micro committing. And that's just a fancy way of saying committing frequently. I like the word micro. That's, what can I say? Micro committing really helps with legacy code because although it's kind of annoying and sometimes it feels like a waste of effort, what it gives me is the next best thing to having tests. If I can't have tests to tell me that I just made a mistake in the last 30 seconds, then at least with a bunch of micro commits, it makes it easier for me to go back and find where I made the mistake. It's not as good as finding the mistake 10 seconds after I make it, but at least knowing where the mistake happened really helps. And so it kind of works like this. Let's say I'm working on code for an hour and a half, and I'm committing every, 30 to 90 seconds. The idea is that when eventually I get to the point where I uncover a mistake, and instead of just saying, well, I made a mistake in the last hour and a half, I guess I have to throw everything away and start again, then I can use something like git bisect to go back over the last 90 minutes worth of work in 30 to 90 second increments and figure out where the mistake was. And that way, maybe I can invest 15 minutes in testing to throw only 40 minutes of work away, instead of having to throw 90 minutes of work away and say, well, at least now I know what I should do. Micro-committing really does provide me the next best thing to having those tests that I'm trying to figure out how to write. So in order to add safety, one of the things that I can do is simply get better at refactoring in general, get better at changing code safely. The more I practice changing code, then the more likely I'll be able to do it accurately, even if you have to take the tests away. And if I commit frequently when I'm, say, test driving new code, then I'll feel more comfortable committing frequently even when I'm working with legacy code. I'll get a feel for how frequently to commit. I'll feel comfortable making a change to 2 or 3 lines of code, changing committing, renaming a function, committing that, moving a function from one class to another, committing that. And it doesn't feel like a wasted effort. It doesn't feel like I'm just committing for the sake of it. What I'm really doing is making it easy to roll back to 38 minutes ago or 39 minutes ago or 41 minutes ago when I make a mistake. These are the 2 big ways that I know how to optimize for safety when working with legacy code. Maybe one of the most important safety techniques in working with legacy code is to become comfortable with the fact that you're going to do an awful lot of unplanned work. Rescuing legacy code is inherently uncertain. And maybe one of the most important mental things you can do is not to try to plan too far ahead. Simply accept the fact that you don't know what you're going to need to do, that you're going to be distracted by things that you notice as you go along. And as a result, you're probably going to do a lot of things that you're going to want to undo. That's part of what micro-committing helps you with. That's one of the reasons to write more tests. But more importantly, recognize that it's inherently uncertain work and don't feel bad about the fact that some days you're going to sit down and you're going to spend an hour working on legacy code, and at the end of that hour, you're going to decide it was all worthless and have to throw it all away. This is part of what it's like to work with legacy code. Anyone who puts pressure on you to be more certain than you are, you simply have to explain to them that this is inherently uncertain work and there's not a lot we can do about it. Unless we just want to throw it all away and build it again, we're going to have to deal with that uncertainty. Any decent contractor who does a job at your house or your office, does any kind of reconstruction, rehabilitating an old property, understands this point. They remind you that although they can have a rough idea what they think the overall project will entail, they tell you, if they're any good, that once they open the walls, anything could happen and we're just going to have to deal with it. And unfortunately, that's a lot what rescuing legacy code is like. So one of the ways that you can optimize for safety is to prepare yourself for to do unplanned work. That's part of the reason that we want to add tests, that we want to micro-commit. Part of the reason that we want to reserve some fixed portion of your capacity to work on legacy code. It's not just because we want to do more paperwork, but it's because that's an integral way to manage the uncertainty, the risk in the inherent uncertainty in working with legacy code. If you're not comfortable working in an uncertain environment, well, spend some time working on legacy code and you will be. It's not enough just to feel comfortable with the uncertainty, but to recognize that rescuing legacy code is a really long-term project. You spent years getting into this mess, and it's going to take years to get out of it. One of the things that I think a lot of people are underestimate with legacy code is just how long it takes. And in fact, sometimes you're never finished. One of the delightful ironies of legacy code is that it's kind of a chronic condition. It gets better some days and worse other days, or maybe it's not as bad after some releases and it's worse after other releases. But to a certain degree, legacy code never really goes away. The code that you're writing right now is probably legacy code for the people who are going to come after you, and they're going to end up writing legacy code for the people who come after them, and so on. And maybe eventually somebody will get it right, but in the meantime, we should probably recognize that not only is rescuing legacy code inherently uncertain work, but we're probably always going to have to do some of it. There's some amount of dealing with legacy code in every project, in every release, no matter how careful we are. And in a way, that's good because that means that we're always practicing working with legacy code. So over the span of our careers, we probably should get better at it, shouldn't we? There's one last piece of advice that I want to offer you before we start looking at the code aspects of dealing with legacy code. And that's something I like to call ask why, but never answer. This came about with my work with teams going through some of their old code. And some of it was their old code, and some of it was code that they'd inherited from past projects. And it usually only took a few minutes of looking at code together, reading it, talking about what we don't like about it, for somebody to start yelling, why did we do this? Or why did they do that? Or why is it like this? In fact, one of the greatest measures that we have of how engaged people are in trying to understand code is the number of times they ask why. And after a few sessions like this, I started to notice that most people, although they're asking why, don't really want an answer to that question. So I instituted a rule. You can ask why, but we don't answer. The reason is simple. When somebody yells why plaintively in that kind of situation, they're not really looking for an explanation. They don't want to hear the story of how the code got to be that way. That's an old Jerry Weinberg line, right? Things are the way they are because they got that way. The story of how it got there can sometimes be interesting or funny or sad. Most of the time it's pretty sad, and it doesn't really make us feel any better. The reason why people yell why in this situation is not because they want to know why, but just because they want to vent about how bad things are. And that's why I instituted the rule. Whenever we're working with legacy code, especially when we're reading code together, or we're talking about something that we want to change, then it's okay to yell why, but we never try to answer that question. Asking why is just a way to vent our frustration about how terrible things are. And so that's why we came up with the rule, ask why, but never answer. So if you're in a situation where you're working with others on legacy code and somebody starts yelling why, just look at them and ask, if I tell you why, are you really going to feel any better? Most of the time the answer is no. This is one of those things that we can do to help each other feel better about working with legacy code. So when somebody asks why, don't answer. It'll just frustrate them. Now it's time to start working on the code part of surviving legacy code. Before I do, one last little reminder. The best time to start rescuing legacy code was 5 years ago. The next best time is now. So no matter what we do in working with legacy code, no matter how long it takes, no matter how frustrating it gets, remember that the best time to start was years ago, and the next best time to start is now. So let's not worry about how good things could have been. Let's try not to dwell on the mistakes of the past. And let's move forward and try to get working on the legacy code now. Let's do what we can, give a chance for the benefits to compound, and hope for the best. It'll be okay. Don't worry.
And this is the point where I have to step in and apologize because
I wanted to show you lots of code here today, but unfortunately, I recorded over 2 hours of video working through the code, and that was way too much to show for this little webinar. And so, while we watch the code flash by us in the background, I'd like to summarize for you the key points that came up as I was working through the code. Before you get too upset at me for making this choice, please keep in mind that there are 2 excellent books that describe more of the design and code aspects of surviving legacy code, and those are Michael Feather's classic book, Working Effectively with Legacy Code, and the more recent Mikado Method by Ulla Elnestam and Daniel Brolund. These are both excellent guides that will take you in detail through the design and code aspects in a way that I simply didn't have time to do today. What I can do instead is take you through some of the highlights of what came up during that 2 hours of video. Before jumping into the code, don't forget to think about the legacy environment that usually comes along with legacy code. This includes things like the version control systems, the build tools, and the runtime containers you need to run your application. A confusing, unreliable environment impacts everything else you try to do to rescue legacy code. This makes it almost impossible to overinvest in rescuing the legacy environment that probably comes along with your legacy code. 2 key micro techniques that go into this are removing manual steps from the build and moving code out of specialized runtime containers so that they can run in plain processes. Rescuing legacy code is hard enough without having to remember to copy files from here to there, or restart that server, or reload this configuration file. When I see an environment issue getting in the way of rescuing legacy code, then I always feel free to drop what I'm doing and address the environment issue, knowing that that's not only going to help me, but that will help make everything related to rescuing this legacy code that much easier. Knowing how difficult it is to rescue legacy code, a lot of people worry about where to start. And the good news is that even though there is, in theory, an objectively best place to start, you probably have absolutely no way of knowing where that is. And so it really doesn't matter where you start. That comes down to personal preference. Some people prefer to use the first day of prison approach, where they go up to the biggest, baddest part of the code base and try to rip it apart. I guess they want to show the code base who's boss. Some people prefer to take a more logical approach, where perhaps they start from the entry point, thinking that, well, the best place to start is to begin at the beginning. So they might look at the entry point of the system, or the constructor of an object, or the entry point of a module to try to start rescuing code. Others like to use the quick win approach. In order to feel better about the job that they're doing, in order to feel less worried about it, in order to feel more comfortable earlier, they look for something relatively easy that they can sort of warm up with. And once they've got a couple of these quick wins under their belt, then they feel more comfortable taking on more of a challenge. To me, any of these techniques work equally well. I don't think any of them is objectively better than the others, but I think they all suit different moods better. And when I feel more hesitant, I might opt for a quick win. And when I feel more confident, then I might just, pretend it's the first day of prison. I think this comes down, as I said, more to personal preference than to there being any objectively best way to do things. All I know is that the best time to start rescuing legacy code was 5 years ago, and the second best time to start is now, so just pick a place and start working. Now I'd like to take you through a quick tour of some of the key code-related techniques that I use to help me survive legacy code. The first of these techniques is called subclass to test, which I learned from Michael Feathers in Working Effectively with Legacy Code. You can most easily think of this as a technique for object-oriented code because it has the word subclass in it. But after you've learned the technique, I think you can see how you could apply it to other programming paradigms. The basic approach involves making a subclass of the class that you're testing in your test, so that you can make changes first in that testable subclass before being forced to make them into production code. When I use this technique, I usually let each and every single test have its own testable subclass of the class that I'm testing. This way I can focus on the variations of that object's behavior that I need for the current test without worrying about how I'm going to make it fit in with the rest of the tests. Over time, changes in these testable subclasses could flow up into the production code, and indeed that's part of the point. By creating a subclass of the class that we're testing in our test, This gives us a safe place where we can sketch ideas about which parts of the object's behavior we need to manipulate, override, eliminate, or change in order to make the current test easier to understand or run at all. This gives us, as I said, a safe place for us to sketch those ideas out. And then, after we've tried that in 5, 6, 7, 8 different tests, the best ideas are the ones that might then flow up into the production code. We can keep those changes in the testable subclasses until we have enough tests or enough confidence that we can make those changes flow up into the production code for everyone to use. One particular difficulty in writing tests for legacy code is knowing exactly what the test is testing. Objects can become complicated. Tangled code makes it difficult to tell the setup code from the action code in a test. By subclassing the test, this gives me a place to move the setup code in order to be able to separate it from the action, which is the objective of each test. I can move that code into an instance initializer or into an overridden constructor to make it clear which parts of the test are setting up the objects to be tested and which part of the test is the point of the test. This makes it much easier to understand these tests over time. In much the same way, subclass to test gives us a place to disable certain parts of an object's behavior while we're checking other parts of its behavior. You know, some legacy code has the problem of too many responsibilities in one place. Rather than breaking the class open and risking hurting some of its clients, we can start by overriding that behavior in these testable subclasses. And we find that we disable the same function in a handful of different tests, and that's a clear signal that we found some behavior that wants to be separated onto its own little collaborating class. Then we can make that change in the subclasses, and once we feel comfortable that this is a change that we want to keep, then we can easily move it up into the class we're testing. This leads naturally into a common step that comes just after subclass to test, and that's replace inheritance with delegation. This is a refactoring from Martin Fowler's classic book, Refactoring, Improving the Design of Existing Code. With this refactoring, we take behavior that we used to vary by subclassing and overriding functions and move them into their own little new collaborating objects. This makes it much easier to run each behavior on its own in isolation from the others. It also makes it easier to confirm that we've implemented them correctly. These two techniques together give us a safe, steady way to break large objects or modules into smaller ones. With subclass to test, we get to identify which parts of an object's behavior should perhaps be separated from each other without having to commit to doing it right away. And once we feel confident that we've got things divided well, then replace inheritance with delegation provides a safe way for code to flow out of the large interdependent module into smaller objects that are easier to compose and easier to understand. Subclass to test, when combined with replace inheritance with delegation, provides a safe, steady way to break large modules into smaller, more easily managed, more easily understood ones. But sometimes it can feel like a slow, arduous, painful process. Sometimes we'd like to jump to the end. We're impatient, we're frustrated. We'd like to use a power tool to get there, and that power tool is introducing pure functions. The mechanics of introducing pure functions are easy to understand and frightening to apply. Introducing pure functions into your objects will make it crystal clear exactly how tangled they are, and that's what's frightening about it. The good news is you know exactly what you need to do to break it apart. The bad news is you see just how much you need to break apart. To introduce a pure function into your system, start with any method on any object in your codebase. Now look at all the places where that method reads from either another field on that object or a globally accessible resource, such as a singleton. Those are the implicit inputs to that method. Now you need to combine those with the actual method parameters, if there are any, and those become all the input parameters to your new pure function. If your language allows it, then you can just name the pure function the same thing as the method. Don't worry, the name will change soon. That was the easy part. Now look at the places where the method writes to the state of the system. It might write to a field on that object, or it might write to something way over there, some kind of side effect. These are the implicit outputs of the system, and you need to combine them with whatever return value that method might have. These are now the outputs of the new pure function. If you have more than one of them and your language doesn't let you return multiple values at once from a function, then you'll probably need to combine those into some little object or struct or data structure that lets you return them from the new pure function. Now you've taken the implicit input parameters from the method and added them to the parameter list of the new pure function so that you can see all the actual inputs that this behavior has to deal with. And you've taken the implicit outputs of the method and you've added it to the return value of the original method so that you can see all the actual outputs of that function. Now copy the body of the method into the new function, and where you used to read from a field, now you can use one of the explicit function parameters. And where you used to write to a field or cause a side effect, now you can add a value or add a component to the return value. What you're left with is a pure function whose behavior doesn't depend on the state of the system and doesn't change the state of the system, but instead operates on its inputs and provides the result through outputs. The good news is that this function is incredibly easy to test. The bad news is that this function is now incredibly tedious to test. This tedium, however, is going to work for you instead of against you, because it's going to help you figure out exactly how to break this function apart into smaller pieces. As just one example, imagine that you have 7 input parameters, and three of those values need to change very frequently for all the different cases that you want to check for this function, and the other 4 change less often. Maybe they're only used in 3 out of the 27 tests you need to write. Well, that's a very clear signal that this function wants to be broken up into 2 smaller functions. One of them operates on just the first 3 pieces of information, and the other operates on the other 4, or perhaps all 7. The fact that you have had to crank through all these permutations of the input, even though 80% of the combinations didn't make sense together, shows you exactly where to break things apart. Yes, you could achieve the same thing through noticing patterns in subclass to test, or even just by reading the code. But by introducing a pure function, it's like making every minor weakness of the code base stand right before your very eyes. You can't miss it. And that's what makes introducing pure functions so effective and so painful. You can see right away exactly all the ways that you should break this code apart. And unfortunately, you can't ignore any of the ways that you should pull this code apart. What is seen cannot be unseen. Broadly speaking, these 2 approaches, subclass to test followed by replace inheritance with delegation, and introduce pure function, can achieve the same goal, helping you figure out exactly where big modules want to be broken apart so that you can break them apart, test them more thoroughly, get to know them more thoroughly, get to understand them more thoroughly, and feel more confident changing them. Of course, these techniques do far more than that, more than I could possibly cover in the time that we have available today. All I can suggest is that you give them a shot, try them out in your code base, and see what you have to learn from them. On those days where I feel more tentative, more unsure about what I want to do, I can always use subclass to test to slowly sketch out ideas about how to break modules apart before I commit to doing it. But on those days when I feel confident and want to charge full steam ahead, I can just introduce pure functions into the toughest parts of the code base and very quickly get an idea of just how bad the situation is and how to pull things apart. Sometimes I start introducing a pure function, I get 30 or 40 minutes into the work, see how terrible it is, and then have to back that out and try the more slow, steady approach. Neither technique is objectively better than the other. I tend to use them to complement each other. Although there's much more to rescuing the design of legacy code than simply subclass to test, replace inheritance with delegation, and introduce pure functions, these techniques form the cornerstone, the foundation of how I safely and surely break large modules and objects apart into smaller ones so that they are easier to understand, easier to test, and easier to change. These key techniques help pave the way for us to be able to apply all the other good software design and development techniques that we would apply to this project if it weren't for all this legacy code. So there we've taken a whirlwind tour through some of the basic code techniques that I use in surviving legacy code. We looked at subclass to test, replace inheritance with delegation. We talked a little bit about golden master, and we looked at introducing pure functions. Now, Those aren't the only things that I ever do to refactor legacy code, but they are some of the key techniques that I use that sort of motivate a bunch of the other decisions. These techniques are really rooted in the idea of either making it easier and safer to tease things apart, like subclass the test, or in making it more obvious how to tease things apart, such as introduce pure functions. And remember, no matter what you do with legacy code, optimize for safety. Commit frequently. Practice refactoring in everyday work so that when you have to do it without enough tests, you can do it more safely. And always be prepared to throw things away. One of the things that makes rescuing legacy code difficult for a lot of people is the inherent uncertainty of the work. It's not just that it's uncertain for the planners, but it's also uncertain for the doers, because you might end up going down the wrong path for an hour and a half and then saying, nope, this was a terrible idea, let's throw it away and start again. You have to become comfortable with this if you're going to survive legacy code. And now we get to maybe the surprising part for many people about working with legacy code, and that's that the code part is the easy part. I find myself rescuing legacy code with sort of the same techniques, code techniques over and over again. Subclass to test, introduce pure functions, golden master. Really, I just go from module to module within a code base, try to figure out how tangled it is, which parts could be easily isolated, which parts require more work to isolate, and then rely on my experience to decide how much to do now and how much to do later. All this is judgment that I've built up over 15 or more years of practice. And that's really where the difficult part of dealing with legacy code comes in. For me, it's not really the code, it's the people. It's the uncertainty of the work. Not only is it uncertain for the people who are expecting results and want to know how long is it going to take and how much it's going to cost. We talked about that earlier. But it's also uncertain for the people doing the work, because you have to be prepared for the possibility that you're going to go down a road for an hour or 2 hours a week and decide to throw it all away. This is why it's so important to use some of the basic techniques like micro-committing and trying to write tests. Your objective there is to make it easier to throw away code, but that's not enough. As a programmer working on legacy code, you have to train yourself to feel comfortable throwing code away. One of the nice things about working with legacy code, if it's code that somebody else has written, is that you feel a certain detachment from the code that you might not feel from your own code. That might make you feel more comfortable throwing work away. Of course, you probably feel pressure to get things done, and that makes you feel pressure to keep work that you're not really happy with. And this is, for programmers, I think one of the central messages. If you want to survive legacy code, then if you're going to rescue legacy code, either do it well or don't do it at all. One of the things that happens when you work on legacy code is that you learn a whole bunch of things not to do. And in the very worst case, you can apply what you've learned there to the new code that you're writing now so that you can write less legacy code for your future selves or for the people who are going to come after you. In any event, if you're going to rescue legacy code, there's no point in half-assing it. You need to do it well, because if you don't do it well, then you're just going to replace their legacy code with your legacy code. And that's really kind of the deep irony, the terrible truth of working with legacy code, that no matter how hard we try, somebody at some point is going to look at our work and treat it like the annoying legacy code that they have to replace. Just like we look at the code that we've inherited and think, oh my, I can't believe I have to deal with this. That's how somebody else is going to think about our code. All we can really do is to learn what makes designs better so that we can make the situation less bad for the people who come after us. And maybe those are just our future selves. I'd like to leave you with one last piece of advice for surviving legacy code, and that's to release the outcome. When I work with legacy code, first and foremost, I refuse responsibility for the quality of the results. I do my best, but there's so many things outside my control that, although it sounds careless and cavalier to say it, really to me it's the only honest way to work with legacy code. To admit that we really don't have very much control over the quality of the results. And that's why we focus on safety. That's why we try to write lots of tests. That's why we micro-commit. That's why we reserve a small portion of our capacity and limit our exposure when working with legacy code. It's to tolerate rather than try to control the uncertainty that's inherent in the work. To me, it's simply a much more honest way to attack the problem. Approaching legacy code this way is probably going to make a lot of people around you nervous. It should make you nervous. That's how you know that you care. But again, refusing responsibility doesn't mean giving up, and it doesn't mean being careless. It simply means recognizing that in spite of the fact that you might do your best and do everything well, it still might not be enough. That's part of what makes it legacy code. In the worst case, what you learn from trying to rescue legacy code will help you write less legacy code next time. Even if it doesn't necessarily help you actually rescue any of the code that you're working on now, what you learn is going to help you both in being better at dealing with legacy code and being better at avoiding legacy code in the future. These skills are going to be hugely valuable to you in the rest of your programming career, so don't discount them. Unfortunately, it won't necessarily make you feel much better. You'd really like to make the legacy code that you're working with now better. Sometimes that's just not in the cards. Let it be the way it's going to be. You have to release the outcome. And here we come to perhaps the fundamental irony of surviving legacy code. And that's that surviving legacy code might not have very much to do with actually rescuing the legacy code.
Thank you, JB. Hello? Now we can hear you, yes.
Excellent.
Thank you for the presentation, and thank you for preparing all that material for us.
You're most welcome.
I am looking at the chat, and people are don't have any questions so far. Either you have explained everything perfectly, or they're just coming right now.
Yes, that's usually it. Either everything was crystal clear or so murky that nobody even knows where to start asking a question.
Well, there are some people that are thanking you for the excellent presentation, so that means something. I don't think was the second option that you presented.
Well, I appreciate that either way. Thanks very much, everyone.
Yes, someone is asking if this will be available. Yes, we will put this presentation online as well. People are all saying thank you. JB, is there anything you can add on top of this? You said that you had some more material that you had prepared, but you didn't have time to put it in here. What was left that you can bring it now and can talk about it?
Well, there's certainly one thing that I did end up having to cut, and that was one of the other techniques that I use. It's called Golden Master. It's a testing technique that I first learned from Keith Stobie in a presentation that I read almost 20 years ago. The basic idea is that if you have trouble, sometimes, especially when we have big systems or we have to test big parts of the system at once, it's hard to articulate or express what the expected result is, maybe because we're not sure what the expected result is or because the expected result is so complicated, like an image, that it's really hard to sort of put the expected value in your insert equals. So the Golden Master technique recommends running the system, capturing the actual output, and then getting someone who knows to look at it and say yes or no, this is okay or this is not okay. And as soon as they look at output and say that output's correct, then you keep a copy of that, and that's called the Golden Master. And then as you do future test runs, the same run of the same part of the system with the same inputs, you can compare the results with the Golden Master. And if the results are the same, then you know you didn't change anything, you didn't break anything when you were changing the code. And if the results are different, that doesn't mean that you made a mistake, but it means you need to look more carefully and see whether something bad happened. Sometimes, like with an image, maybe the image changes in a way that is something that a human eye would tolerate, but that a computer wouldn't because the bits are different. So then you just say, well, now this is what the new Golden Master looks like. And you can use this with whatever output your system already provides to sort of give you a leg up in getting some end-to-end tests to help you start refactoring. It's not as good as writing smaller tests, but it's better than nothing.
Meanwhile, people are sending some questions here. So, first of all, we have David that is saying that he uses your 7-minute, 26-second videos all the time and talking about TDD, and he will be adding this one as well. So, congratulations, you have a new fan.
Thank you.
A fan that is going to follow you more. From Mike here, do you have any advice for dealing with legacy code where significant pieces of business logic, in quotes, are stored in SQL? That's an interesting one.
Yes, the first thing to keep in mind there is that on its own is not necessarily a bad thing. It doesn't necessarily. The one thing the one problem it creates is that we might not have good tools for running and testing that stuff. So the first thing is learn the tools that will help you run your SQL code and be able to test it on its own. Whether that means testing tools like, I think it's called TSQLT, that can actually help you write tests in the native SQL code environment, or using whatever programming language you normally use to just round trip to the database. The important thing is don't try to test your business logic in SQL with your application logic in whatever programming language you use at the same time. This is where a lot of people get into trouble. If you want to check the business logic running in SQL, run just the SQL on its own and don't worry about the rest of the application. If you want to check your application code, don't run it through the SQL. That's where you can break the two apart and provide a backend that's maybe not a real SQL database or is an implementation of an interface that just feeds back hard-coded data. I think that's really where people get into trouble, is when they try to run their business logic in SQL and their application at the same time. So separating them is really important. I'm trying to remember exactly. I'll type it in here. I believe the website is sqlity.net. I tried putting it in the chat window for everyone. That is those, assuming that they're still writing there, those are friends of mine who know more than anybody I know about how to do unit testing or test-driven development with SQL code.
Wonderful. It's good to bring your friends over because that means that you trust them.
Absolutely.
Another question we have, with regards to surviving the people part, what are some techniques you can use with stakeholders to make them comfortable with the inherent challenge aspect that we may not get the bang for the buck?
Yes. So, David, since you mentioned my 7 minutes, 26 seconds video, I think that is probably one of the places to start. This relates to the article I wrote a couple of years ago called The Internal Struggle Between the Business and Programmers. One of the hardest things about the relationship between stakeholders and programmers is they have this perception that programmers want to refactor and that this is some kind of luxury time that they are adding on to the cost of development, whereas the stakeholders think that if they can push the programmers to design less well, that they'll get more features sooner. And that works for a little while, but that's where legacy code comes from. I think one of the key techniques, or one of the key points to bring up with stakeholders, is to really explain to them that the time that programmers want to take to design things better, not even necessarily well, but better than they've been doing, has their best interests in mind. The goal is, and this is the phrase that I like to use that impresses people when they hear it for the first time, so it's a cheap trick that you can use. All we're trying to do is reduce volatility in the marginal cost of features. Of course, everybody wants that, don't they? So then you pause for a few seconds, and if they understood you, great, and if they didn't understand you, then you can say to them, well, I'm talking about trying to reduce uncertainty in the cost of getting the next feature. The more time that, right now, when I cut corners in design, what ends up happening is not just the cost of features goes up, but the amount of uncertainty in the cost of the features goes way up. I really have no idea how long anything's going to take to build because I have to tiptoe around all this bad design. And when we're working with legacy code, that's just code where we've cut those, somebody, maybe not we, but somebody has cut those corners thousands of times over the last decade. Or maybe we've cut those corners a bunch of times over the last 2 years. And so it's especially important when working with legacy code to help people understand the way, people understand that when we want to take time to design things better, we're doing it because we want to smooth out the cost of adding new features. Unfortunately, that means that to this point, we've probably been going faster than we can. And this is the hardest thing to help stakeholders become comfortable with, to help them really believe. And the only thing I know how to do is to keep trying to have honest conversations with them and to keep at it. Talk to them, take them out for coffee, sometimes maybe wine or something stronger, and really have an honest discussion with them about about the cost of shipping features. And ignoring the design, letting the design decay, rot, whatever metaphor you want to use, just drives not only the cost of features up, but uncertainty in the cost of features up. They know this, but I have a feeling that a lot of stakeholders worry that programmers have adopted this idea of wanting to refactor not out of any practical value, but out of a sense of, I don't know, entitlement or as a way of seizing control in the relationship. Maybe the single best thing you can do is to show the stakeholders that you understand and care about driving down the uncertainty in the cost of features, and that's why you care about design. Martin Fowler has this great slide from a presentation that he gave a few years ago. I don't know, it was floating around Twitter a couple of years ago, that essentially had, here are all the reasons to refactor. And there were a bunch of them, we want elegant code, we want blah, blah, blah. I don't even remember what they all were. With just a big X through them and the word money, in front of all of it. Because really that's the only reason to care about refactoring. The reason that we care about improving the design of our systems is not out of any sense of elegance or beauty or excellence for its own sake. It's because we as programmers understand that when we take care of the design, then when we go to add a feature, it doesn't matter what feature we add, it doesn't matter when we add it, there's, I won't say no, but there's much less unexpected cost than there otherwise would be. And so sometimes I think just expressing that to stakeholders, letting them know that you're on their side, that you're not doing this because you want to, but you're doing this because it's in their best interest. Maybe they just need to hear that. The other unfortunate thing that they need to hear, so that's the sugar. The medicine that has to go along with that is you recognize that we've been going way too fast all this time, don't you? And you can always use the metaphor of, how easy is it to steer a car when you're driving 185 kilometers an hour? And what they've been trying to do is drive a car 185 kilometers an hour that's designed only to go 140, and they're trying to steer, and they wonder why they're crashing. That's what happens when stakeholders put pressure on programmers to cut corners with the design and just pump features out. All we can do is have those conversations more often, more honest, and to make sure that we let the stakeholders know that we're not doing this because we want elegance or excellence, that we're doing this for the same reasons that they care about smoothing out the cost of adding new features.
Thank you, JB. And we don't have more time for questions. I'm going to take the presentation right now from you. And I'm Ardita. I remember I forgot to introduce myself earlier. And on behalf of the Toronto Agile community, I want to thank you for this personal time with us. You took your time to record and to answer the questions. So thank you very much. For everyone that attended this webinar, this was our first webinar and we are trying to build some more. So please go to our website, you know where we are, send us some feedback and suggest to us some future topics that will help us bring to you more useful and more interesting sessions that are going to help you. It is all about you. I wanted also to remind you about some events that we are planning along the way. We have the open space on Saturday, April 9th. make sure you are there. It is one of our events that we are proud to host, and we are preparing really nice for that. The second one, we have nailed down the date for the Toronto Agile Conference. It's going to be on November 14th, and we promise it's going to be as good or maybe even better than the years before. I don't know if you are seeing right now my screen, maybe not. Probably I wanted to show you this screen when I was talking about. now I go ahead. So again, thank you everyone. Thank you JB, and we'll talk again on other events. Bye.